We are going to build a fully custom AI agent, host it securely in the AWS cloud, and get a live, instantaneous response. To do that, we will use the AgentCore CLI tool to turn a completely blank local directory into a live, containerized TypeScript agent. Before we run the first command, look at this checklist. You need 4 things installed and active: a configured AWS CLI, access to Amazon Bedrock models, Node.js version 20 or higher, and a local container runtime like Docker. Getting these 4 tools running locally right now ensures we avoid cascading authentication and build failures later when we push to the cloud. Step 1 is installing the AgentCore CLI globally via npm. Once that finishes, we create our project workspace, adding the no agent flag so we start with a clean slate. This setup command generates an AgentCore directory. This folder acts as the control center, mapping your local deployment targets directly to AWS. Next, we inject our TypeScript agent. We tell the CLI to add a bring your own container-built agent, specifying TypeScript and the Strands framework. Inside the agent directory, we initialize our node environment. Then we install our required packages, including the Amazon Bedrock AgentCore SDK and the Strands SDK. When you run that command, look at this terminal flag. You must append -- legacy peer deps. This flag resolves dependency conflicts between the Strands SDK and OpenTelemetry. By scaffolding the project this way, we separate our core agent logic from the AWS infrastructure. The code is entirely environment agnostic. Inside our workspace, the generated agent.ts file acts as the router. It uses the Strands framework to listen for an incoming text payload, process the prompt, and return a response. We package that logic into a Docker container. A multi-stage build separates the bulky build environment from the lightweight production environment. Stage 1 compiles TypeScript to JavaScript, dropping developer libraries. The lean JavaScript then moves to production, securing the container and opening 3 networking ports. Before we build the final container, we run a local compilation test. Running npm run build traps simple syntax errors early. Executing this multi-stage container strategy guarantees our agent will run exactly the same way on your laptop as it will on a massive cloud cluster. Now we map this local code to our cloud infrastructure. Open the AWS targets JSON file and input your specific 12-digit AWS account ID and your target region. Run AgentCore validate. This mathematically checks the formatting of your configuration files to ensure AWS will accept them. With the configuration verified, execute AgentCore des. This spins up a local development server, building the Docker image and hosting the agent so we can query it in isolation. If that local boot fails because another process is using port 8080, bypass the block by running the command again with an explicit port override flag, like --port 3000. To test it, open a second terminal. Send a query to the agent from this new window, and watch your primary dev server terminal ingest and process the payload in real time. Validating the agent locally proves your code works. If we hit errors during remote deployment, we know it is exclusively an AWS permission issue, removing code logic from the equation. It is time to push to the cloud. Execute AgentCore deploy. Look at this deployment path. AWS code build takes our local source, assembles the Docker image, and registers it into an Elastic Container Registry. Then, the Cloud Development Kit spins up security roles and provisions the Bedrock AgentCore runtime to host our image. When the deployment completes, the terminal will output a unique agent ARN identifier. Save this string. You strictly require it to grant any external applications programmatic access to your agent. That single deployment command fully abstracted the underlying infrastructure, transforming our local logic into a highly available microservice. To prove the connection, we run AgentCore invoke followed by a text prompt to send a ping directly to the fully deployed Bedrock agent. Instantly, the generated text response from our newly deployed cloud architecture streams all the way back down to our local machine. When you finish testing, execute AgentCore remove all --yes followed by AgentCore deploy. This sequence aggressively deletes all provisioned AWS resources to prevent any passive billing accrual. You now command a repeatable, scalable framework to develop, validate, and securely host custom enterprise AI logic on AWS.